Hello everyone, welcome to lecture 10 of CIN 603, and in this lecture we shall be looking at system architecture. The objectives of the lecture are to provide a checklist of issues to consider when selecting a system architecture, to describe servers, server-based processing, clients and client-based processing. 3, explain client-server architecture, including tiers, cost-benefit issues, and performance. 4, compare in-house e-commerce development with packaged solutions. 5, discuss the potential impact of cloud computing and Web 2.0. 6, explain the difference between online and batch processing. Next, we shall be looking at defining network topology, including hierarchical, buzz, ring, and star networks. Next is explain network protocols and licensing issues. Number 8 is describe wireless networking, including wireless standards, topologies, and trends. And finally, we shall describe the system design specification. Introduction. A system architecture is the conceptual model that defines the structure, behavior, and more views of a system. An architecture description is a formal description and representation of a system, organized in a way that supports reasoning about the structures and behavior of the system. An effective system combines elements into an architecture or design that is flexible, cost-effective, technically sound, and able to support the information needs of the business. System architecture translates the logical design of an information system into a physical structure that includes hardware, software, network support, and processing methods. System architecture checklist. Enterprise Resource Planning, ERP. A ERP refers to a type of software that organizations use to manage day-to-day business activities such as accounting, procurement, project management, risk management and compliance, and supply chain operations. The objective of a ERP is to establish a company-wide strategy for using IT resources. Supply chain management, SCM, is the optimization of products creation and flow from raw material sourcing to production, logistics, and delivery to the final customer. Initial costs is a cost undertaken to establish a desired system. TCO, total cost of ownership, is an estimation of the expenses associated with purchasing, deploying, using, and retiring a product or piece of equipment. Total cost of ownership or actual cost quantifies the cost of the purchase across the product's entire life cycle. During the final design stage, you make decisions that you have a major impact on the initial cost and the TCO for the new system. Still continuing on system architecture checklist, scalability. Scalability, also called as extensibility, refers to a system's ability to expand, change, or downsize easily to meet the changing need of a business enterprise. Especially important in implementing systems that are volume rated, such as transaction processing systems. Scalability will help your company retain its product quality throughout expansion without sacrificing the efficiency or quality of your customer service and internal operations. This seamless operation will keep your employees well versed in company changes while maintaining positive relationships with your customers. Web integration. The word web integration generally comes from the word system integration. System integration is defined in engineering as the process of bringing together the component subsystems into one system and ensuring that the subsystems function together as a system. Web integration, web data or web integration or web data integration is the process of aggregating and managing data from different websites into a single homogeneous workflow. This process includes data access, transformation, mapping, quality assurance, and fusion of data. Data that is sourced and structured from websites is referred to as web data. Use of World Wide Web for information systems is considered an ideal solution in this technology-oriented world. It brings abundance of ease of use and avoids in-house costs, avoids many of the connectivity and compatibility problems that typically arise. System architecture checklist continued. Legacy systems interface requirements. So first of all, let's go and define what legacy systems are. A legacy system is an old or outdated system technology or software application that continues to be used by the organization because it still performs the functions it was initially intended to do. Generally, legacy systems no longer have support and maintenance, and they are limited in terms of growth. However, in many cases, a newly developed system will have to be interfaced with a legacy system. Interfacing a new system with the legacy system involves analysis of data formats and compatibility. The analyst must know if the new application eventually will replace the legacy systems. With this information, the system analysis may be able to plan and forecast future events in regards to the system. Processing options. In planning the architecture, designers also must consider how the system will process data online or in batches. Provision must be made for backup and speedy recovery in the event of system failure. Online processing is done real time. Batch processing occurs after a period of time or in intervals. Backup and disaster recovery plans need to be looked into for unforeseen circumstances. Checklist on security issues. Security threats and defenses are a major concern to a system analyst. The system analysis must consider security issues that relate to system design, specification. Web-based systems introduce additional security concerns. Common security concerns in relation to information systems, especially those which are web-based, include privilege escalation, virus, worm, Trojan, spyware, spam, adware, and rootkits. Typically, project managers work with their team outlining the design scope of the project. During the process, the team takes into account all aspects of the project, including budgetary, structural requirements, shapes, views, and other design options. Common architectures used in information system development is the client-server architecture, whereby a client requests for information and the server corresponds. A server is a computer with a large processing capability, memory, and storage capabilities that provides resources. As the PC technology exploded in the mid-90s and the 1990s, powerful microcomputers quickly appeared on corporate desktops. Users found that they could run their own word processing, spreadsheet, and database applications. Companies linked these standalone computers into networks. A client is basically a device on a computer network that requests for the information, and generally it requests information from a larger computer known as a server. The illustration shows the architecture of a client-server network. As aforementioned, a client requests for information and the server responds to it. The basic difference between both terms is that, now when we look at the basic difference here, we're looking at the difference between fat and thin clients. So the basic difference between both these terms is that thin client uses a remote computer for processing an application, whereas the thick client does the application processing by itself as it runs locally on the application. Where a difference between the two can be realized in the table in the slide. A Fed client generally in a network traffic is higher because the Fed client, pardon me, in network traffic, the Fed client, generally the traffic is higher because the Fed client must communicate more often with the server to access data and update processing results. Network traffic in a thin client is lower because most interaction between code and data takes place at the server. The performance with a Fed client is slower because of more traffic is required. Thin client, the performance is faster because less traffic is required. With Fed client, the initial cost is higher because more powerful hardware is required. With a thin client, lower because workstation hardware requirements are not as stringent. The maintenance cost for a Fed client is higher because more program code resides on the client. For a thin client, the maintenance cost is lower because most program code resides on the central server. With a Fed client, it is easier to develop because the system resembles traditional file server designs where all processing was performed at the client. With a thin client, more difficult because the developers must optimize the division of processing logic. Client-server architecture. Within the client-server architecture, we have a software which is known as a middleware. Middleware is the software that runs between the client and the server processes. It is the glue between the client and the server, which makes it possible for them to communicate to each other. Middleware is written in such a way that the user never notices his presence. It delivers secure and transport services to users. It enables the tiers to communicate and pass data back and forth, provides a transparent interface, can integrate legacy systems and web-based applications. Cost-benefit issues when it comes to client-server architectures. The client-server system enables the firm to scale up the system in a rapidly changing environment. Client-server computing also allows companies to transfer applications from expensive mainframes to less expensive client platforms. Client-server systems reduce network load and improve response times. Client-server performance issues. In contrast to the centralized system, a client-server design separates applications and data. Distributed Database Management System, DDBMS, hence data can be accessed from various locations, giving room for disaster recovery procedures. The system is scalable, so new data sites can be added without reworking the system design. The system is less likely to experience catastrophic failures. What are some e-commerce solutions? This is some of the questions that need to be answered before deciding to develop an e-commerce solution in-house. An economic solution to specialized software which can help you to sell online is e-commerce solution. You don't need any technological skills because it is designed to give you all the tools you need. There are hosted and self-hosted version depending on your store's need. So some common guidelines for in-house e-commerce site development include analyze a company's business needs and develop a clear statement of your goals. Consider the experience of other companies with similar projects. Obtain input from users who understand the business and technology issues involving in the project. Plan for future growth, but aim for ease of use. Determine whether the IT staff has the necessary skills and expertise to implement the project. Consider training, additional resources, and the use of consultants if necessary. Consider the integration requirements for existing legacy systems or enterprise resource planning. Select a physical infrastructure carefully so it will support the application now and later. Develop the project in modular form so users can test and approve the functional elements as you go along. Connect the application to existing in-house systems and verify interactivity. Test every aspect of the site exhaustively. Consider a preliminary rollout to a pilot group to obtain feedback before a full launch. Internet-based architecture, package solutions, and e-commerce providers. Now, many vendors offer turnkey systems for companies. Turnkey is a computer system purchased from hardware and software vendors, customized and put in working order by a firm that then sells the completed system to the client that ordered it. Another alternative is to use application service provider. An application service provider, or ASP, is a company that offers individuals or enterprises access to applications and related services over the internet. Another option is managed hosting. Managed hosting service is a type of internet hosting in which the client leases an entire server not shared with anyone else. Consider the experience of other companies in the same industry. Research on similar firms and their experiences. Still on internet-based architecture, corporate portals. Corporate portals are used by corporations to build their internal web presence by leveraging a company's information resources. Cloud computing, simply put, cloud computing is the delivery of computing services, including server, storage, databases, networking, software, analytics, and intelligence over the internet. That is the cloud, to offer faster innovation, flexible resources, and economies of scale. Now, cloud computing effectively eliminates compatibility issues. It produces scaling on demand, moreover requires significantly more bandwidth. Web 2.0 under internet-based architecture. Web 2.0 describes the current state of the internet, which has more user-generated content and usability for end users compared to its earlier incarnation, Web 1.0. In general, Web 2.0 refers to the 21st century internet applications that have transformed the digital era in the aftermath of the dot-com bubble. Web 2.0 refers to the websites that emphasize user-generated content, ease of use, participatory culture, and interoperability for end users. Wiki is a hypertext publication collaboratively edited and managed by its own audience directly. An Internet Operating System, or Internet OS, is any type of operating system designed to run all of its applications and services through an internet client, generally a web browser. Online processing. Now, if we look at processing methods, generally there are two. We have online and batch processing. So first of all, let's have a look at online processing. Online processing is an automated way to enter and process data or reports continuously as the source documents are available. Because it is interactive, online processing avoids delays and allows a constant dialogue between the user and the system. Online processing also can be used with file-oriented systems. A very good example of online processing is an ATM. Batch processing. Batch processing is the processing of transactions in a group or batch. No user interaction is required once batch processing is underway. The IT operations group can run batch programs on a predetermined schedule without user involvement during regular business hours, at night, or on weekend. Requires significantly fewer network resources than online systems. Combined methods. Combined methods includes the combination of both online and batch processing. Combined processing is very common with current technology. A very common example is a process involved with the point of sale available in the supermarkets. Every transaction occurrences does online in automatic inventory updates, whereas batch processing takes place in the preparing of the records at the end of the day, thus attaining the daily sales. Network models. The OSI model. The OSI, the long form for OSI, is Open Systems Interconnection. So the open systems interconnection model is a conceptual model that describes the universal standard of communication functions of a telecommunication system or computing system, without any regard to the system's underlying internal technology and specific protocol suites. In the OSI reference model, the communications between a computing system are split into 7 different abstraction layers. These include physical, data link, network, transport, session, presentation, and application. Network models. First of all, let's have a look at network protocol under network models. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. Common network protocols include TCP/IP and FTP. TCP/IP, which is Transmission Control Protocol, Internet Protocol, is a suite of communication protocols used to interconnect network devices on the internet. File Transfer Protocol is a standard communication protocol used for the transfer of computer files from a server to a client on a computer network. Network topology. Network topology is the arrangement of the elements of a communication network. Network topology can be used to define or describe the arrangement of various types of telecommunication networks, including command and control radio networks, industrial field buses, and computer networks. So the first type of network topology that we shall be looking at is hierarchical network. The hierarchical topology model is made up of the following: a core layer of high-end routers and switches optimized for network availability and performance, a distribution layer of routers and switches implementing forwarding decisions, an access layer connecting users via hubs, bridges, switches, or routers. The advantage is that this topology provides high scalability. The disadvantage of hierarchical network is that if a business adds additional processing levels, the network becomes more complex and expensive to operate and maintain. Bus network. Bus topology, also known as line topology, is a type of network topology in which all devices in the network are connected by a central RJ45 network cable or coaxial cable. The single cable where all data is transmitted between devices is referred to as the bus. Devices can be attached or detached from the network at any point without disturbing the rest of the network. The major advantage of a bus network is that it is cheap to set up. The disadvantage is that the overall performance declines as more users and devices are added. And do note that the bus network has become obsolete over the years. Ring topology. Ring network is a network topology in which each node connects to exactly 2 other nodes, forming a single continuous path for signals through each node. That is a ring. Data travels from one node to another, and each node along the way handling every packet. The advantage of ring network is that higher transfer rate, it is cheap to install, and has minimum collision. Disadvantage is that the disadvantage is that in a ring network, if a network device fails, such as a PC or a server, the devices downstream from the failed device cannot communicate with the network. Star network. In a star network, every host is connected to a central hub. The central hub may be a switch. The major advantage of a star network is that it is very reliable. If one cable or device fails, then all the others will continue to work. It is high performing as no data collisions can occur. The disadvantage of star design is that the entire network is dependent on the central hub, that is the switch. Mesh network. A mesh network is a local area network topology in which the infrastructure nodes connect directly, dynamically, and non-hierarchically to as many other nodes as possible and cooperate with one another to efficiently route data to and from clients. The major advantage is that it provides a lot of redundancy, which helps keep the network running even if problems exist. The major disadvantage is that it is expensive to formulate, install, and maintain the network. Network models, routers. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions on the internet. It can connect to a larger or dissimilar network such as the internet. A router interconnects networks. Networking modeling tools. As you translate OSI logical model into a physical model of the network system, you can use software tools. A very good example of a software tool to do so is a network modeling tool. It allows the development of logical designs of a network. A very good example of a network modeling tool is Packet Tracer. Wireless network. A wireless LAN is a wireless computer network that links two or more devices using wireless communication to form a local area network within a limited area, such as a home, school, computer lab, campus, or building office. The IEEE 802.11 is a part of the IEEE 802 set of local area network technical standards and specifies the set of media access control and physical layer protocols for implementing wireless local area network computer communication. Wireless networks. Let's look at some of the wireless trends. The Wi-Fi Alliance is a non-profit organization that owns the Wi-Fi trademark. Manufacturers may use the trademark to brand products certified for Wi-Fi interoperability. Wi-Fi is a family of wireless network protocols based on the IEEE 802.11 family of standards, which are commonly used for local area networking of devices and internet access, allowing nearby digital devices to exchange data by radio waves. Bluetooth is a short-range wireless technology standard that is used for exchanging data between fixed and mobile devices over short distances. WiMAX, the long form for WiMAX is the worldwide interoperability for microwave access. It is a communications technology aimed at providing wireless data over long distances in a variety of ways, from point-to-point links to full mobile cellular type access. Systems design completion. System design specification. A typical system design specification typically includes the following sections. Management summary. Management summary is a brief overview of the project for company managers and executives. It outlines the development efforts to date, provides a current status report, summarizes project costs, reviews the benefits of the new system, presents the system implementation schedule, and highlights any issues that management needs to address. System components contains the complete design for the new system, including the user interface, outputs, inputs, files, databases, and network specifications. You include source documents, report and screen layouts, BFDs, and other relevant documents with system components. Also, include the requirements for all support processing, such as backup and recovery, startup processing, and file retention. System environment describes the constraints or conditions affecting the system, including any requirements that involve operations between Operations, pardon me. System environment, let's start all over. System environment describes the constraints or conditions affecting the system, including any requirements that involve operations, hardware, system software, or security. Examples include transaction volumes that must be supported, data storage requirements, processing schedules, reporting deadlines, and online response time. Implementation requirements specifies startup processing, initial data entry or acquisition, user training requirements, and software test plans. Time and cost estimates provide detailed schedules, cost estimates, and staffing requirements for the system development phase and revise projections for the remainder of the SDLC. You also present total costs to date for the project and compare those costs with your prior estimates. And finally, additional material. This can be included at the end of the system design specification. You might insert documents from earlier phases if they would be helpful to the readers. User approval. Users must review and approve the interface report and menu designs, data entry screens, and source documents and other areas of the system that affect them. Other IT department members also need to review the system design specification. When the system design specification is complete, you distribute the document to a target group of users, IT department personnel, and company management. For the entire organization to work effectively and cooperatively, each user needs to go through the design and system components before it is being implemented. This is to ensure that each user takes ownership of the system and works productively. Finally, presentation. The first presentation is to the system analysts, programmers, and technical support staff members. Your presentation is to department managers and users from departments affected by the system. The final presentation is for the company management. Management might reach one of the three decisions, either to proceed with the system development, to either perform additional work on the system design phase, or finally, the last option is to terminate the project. Summary. An information system combines hardware, software, data, procedures, and people into a system architecture. The analysis must consider enterprise resource planning, initial cost, and TCO, scalability, web integration, legacy interface requirements, processing options, and security issues. An architecture requires servers and clients forming a client-server architecture. Compared to file server designs, client-server systems are more scalable and flexible. In implementing a design, an analyst should consider e-commerce strategies, the availability of packaged solutions, and corporate portals, which are entrances to multifunctional websites. The primary processing methods are online and batch processing. Networks allow the sharing of hardware, software, and data resources in order to reduce expenses and provide more capability to users. The way a network is configured is called the network topology. The system design specification presents the complete systems design for an entire system. And this finishes our very last lecture for CIN 603. Thank you for listening, everyone, and thank you for your time. Goodbye.